In this video, we will explore the question, why do we need machine learning explanations? Before we dig a little deeper into machine learning explainability, let us pause for a moment and ask the question, why do we use machine learning? This slide presents a sample problem of classifying images to answer a question, is this a tree? As you can clearly see, we have a variety of tree species, representations, and shapes, and it is extremely difficult to solve the problem with predefined rules. Rather, we turn to machine learning methods to solve this problem by learning from data. We feed learning algorithms enough examples of tree and non-tree images along with the right answer. And with enough examples, our learning algorithms discover their own rules to accomplish the task of mapping input features to a prediction without being explicitly programmed. In some cases, these algorithms are able to exceed human-level performance at accomplishing their assigned task. Note, there is some uncertainty baked into the process. But if the job is getting done correctly and we can tolerate some level of uncertainty, then we can deploy our tree classifier model into the wild and start using it. We run into issues where trusted machine learning algorithms start to perform tasks by doing things we did not expect or want. In this example, the task was to predict health outcomes based on X-ray images of lungs. It would have been ideal if the machine learning algorithm generated knowledge by discovering new ways of identifying disease. Instead, the machine learning model ignored the lungs and focused on the text in the corner of the image. The one image with the red region shows the outcome of an explainability technique called saliency map. This is highlighting the area of the image in which the algorithm focused on when coming up with a prediction. Interestingly, the algorithm based its prediction on the text representing the type of unit. So the text portable became a proxy for patients too sick to move, and the X-ray unit had to come to them. The text emergency became a proxy for patients needing an X-ray image in an emergency setting. And the text for inpatient units became a proxy for patients that scheduled their appointments in advance. Yes, the association between X-ray unit type and health outcomes is interesting, but it is not what we wanted or expected. If all of a sudden I stopped showing text in my X-ray images, my biased machine learning classifier will not perform well. It turns out that the very reason we turn to machine learning to solve problems, their ability to independently learn from data without being explicitly programmed, is also the reason we need human oversight to make sure these algorithms learned a solution that is acceptable to us and will generalize well to new unseen data. This slide captures an example from the literature showing deep neural networks correctly identifying images of guitars and penguins and doing so with a high degree of confidence in the order of 99%. But also images that are clearly not guitars or penguins are incorrectly classified with the same level of confidence as the correct predictions. This goes to show that under the right circumstances, it is easy to fool machine learning algorithms. This slide captures another example from the literature where altering a single pixel on an image is enough to get a machine learning model to classify it incorrectly. These types of adversarial attacks are known as one-pixel attacks. It goes to show that we need some understanding of the logic of our machine learning models in order to understand their vulnerabilities and to address them. In some cases, we need explainability to comply with regulatory requirements, such as the Equal Credit Opportunity Act governing the US financial sector, and GDPR and the right to an explanation of an algorithmic decision for European citizens. So the answer to the question, why do we need machine learning explanations, is that explainability leads to trust in our machine learning models, and trust in our models lead to adoption. This is particularly important for high-stakes decisions.